Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is handling of residual solvents in pharmaceutical manufacturing, the basic understanding. Residual solvents. Residual means leftover. Let us understand on the residual solvents topic. By definition, it is traces of organic solvents present in the product after the final stage. Residual solvents in pharmaceuticals are traces of organic volatile chemicals that are present when used or produced in the manufacture of drug substances or excipients or in the preparation of the drug products. Depending upon the process requirement, various solvents are used as vehicles for carrying out the reactions. Product isolation. After the process, the solvents are removed by various methods to make the product free from any such solvents. It is similar to cooking food with water. After the food is processed, in the final stage of isolation, there is no excess of water or limited amount of water will be present in the final product. The solvents are not completely removed by practical manufacturing techniques. Obviously, complete removal of solvents may not be possible practically or not necessary to remove completely. ICH Q3C R8 or USP 467 are the guidelines that describe the requirements. These guidelines give detailed insight into the handling of residual solvents. The content in both references is almost same. Since there is no therapeutic benefit from residual solvents, all the residual solvents should be removed to the extent possible to meet the product specifications, good manufacturing practices or other quality based requirements. So we know that there is no therapeutic value for the solvents present in the product. Obviously, it is necessary to remove the residual solvents to the extent possible. Extent possible means that it may not be possible or necessary to remove the residual solvents down to not detectable levels. So, extent possible means to remove till it is no longer any health hazard for the consumer. It is not necessary or possible to remove till the product is bone dry. In fact, it may deteriorate the product quality if tried to do so in many cases. They have to be controlled as per the prescribed limits. Having described above, it is necessary to control the residual solvents within the acceptable limits. Let us see how the prescribed limits are established in the next slide. Let us see how the prescribed limits are established. The method used to establish the permitted daily exposures, that is PDE, for residual solvents is derived from the no observed effect level, that is NOEL, or the lowest observed effect level, that is LOEL, in the most relevant animal study. The information on the PDE is not described in detail here. A brief explanation is given here. The scope of this video is limited to handling of residual solvents in the pharmaceutical products. For detailed information, refer recent guide, the impurities guidelines for residual solvents Q3C revision R8 dated April 22, 2021. So it should be understood that the permitted daily exposure is derived from NOEL or LOEL in the animal study. The toxicity data will be used to establish limits. Toxicity data is also considered for establishing the limits. This study takes into consideration the levels of toxicity, type of toxicity, duration of exposure of such materials, etc. There are two options for describing the limits of the solvents. Option 1 data is calculated as concentration in ppm, that will be 1000 into PDE by dose of 10 grams per day. For example, the PDE of toluene is 8.9 mg per day. The calculation is 1000 into 8.9 divided by the dose, the 10 grams per day, which comes out to 890 ppm. Same type of calculation is done for all other solvents also. Option 2 may be applied by adding the amounts of residual solvent present in each of the components of the drug product. The sum of the amounts of solvent per day should be less than that given by the PDE. Option 2 considers residual solvents from each component of the drug product and should be less than the PDE. Individual component may not pass option 1, but the total in the drug product may pass to the requirement. Based on the PDE, solvents are classified as three classes. Class 1 solvents, solvents to be avoided because they are known human carcinogens, strongly suspected human carcinogens, and environmental hazards. Class 2 solvents, solvents to be limited. They are non-genotoxic animal carcinogens or possible causative agents of other irreversible toxicity such as neurotoxicity or teratogenicity. Solvents suspected of other significant but reversible toxicities. Class 3 solvents, solvents with low toxic potential. Solvents with low toxic potential to man, so no health-based exposure limit is needed. This is the list of class 1 solvents with the maximum limits prescribed. This is the list of class 2 solvents with the limits prescribed. This is the list of class 3 solvents for which the limit is not more than 0.5%. Let us see some information on other solvents. The solvents other than listed in any class 1, 2, 3 may also be of interest to manufacturer of excipients, drug substances or drug products. This point is important to explain. Any solvent that is not a part of any of the classified solvents is considered as class 4 solvent. The reason for not including in the list is that adequate study has not yet been done for such solvents and hence adequate data is not available. However, when no adequate toxicological data on which to base a PDE was found, manufacturer should supply justification for residual levels of these solvents in pharmaceutical products. So, it is the responsibility of the manufacturer to establish the nature of the residues of the solvents and its impact on the toxicity of the solvent on the consumer. detailed study as prescribed in ICH Q3C needs to be submitted to establish the PDE. Based on the PDE, the limits may be assigned. This declaration is important. Manufacturers of pharmaceutical products need certain information about the content of residual solvents in excipients or drug substances in order to meet the criteria of this guideline. It is not necessary to screen the final product for all solvents listed. The manufacturer should provide the list of solvents used in the process steps in all stages, its classification, and its presence in the final product. Acceptable examples of the information that could be provided from a supplier of excipients or drug substances to a pharmaceutical manufacturer are provided in the next slide. Some of the example statements are provided in the next slide on the declaration of residual solvents. The supplier might choose one of the following, which is there on the next slide, as appropriate. The following statements may be made. Only class 3 solvents X, Y, etc. are likely to be present. Loss on drying is less than 0.5%. So, if only class 3 solvents are present, this statement would suffice. Here it is necessary to declare the list of class 3 solvents used in the process. Class 2 solvents X, Y, etc. are likely to be present. All are within the acceptable limits. Here the supplier would name the class 2 solvents represented by X, Y, etc. So this statement will be okay for class 2 solvents. Class 1 solvents X, Y, etc. are likely to be present. All are within the acceptable limits. So as in the case of class 2, a similar statement can be made for class 1 also. No class 1 solvents are used in the process. If there are no class 1 solvents used in the process, it can be declared so. Let us see the strategy for controlling of residual solvents for routine manufacturing. Guideline for residual solvents CPMP ICH 283/95 gives complete details on residual solvents. This guideline prescribes where class 1 solvent might be present in another solvent, example toluene or acetone containing benzene. A routine test for this class 1 solvent on a suitable intermediate or the final active substance is not required when the limit applied to the originator solvent is such that the class 1 solvent will be present in the active substance at a levels below the limits set out in the guideline. Let us see this example. If there is a solvent that has raw material source of class 1 solvent used, it is necessary to screen for the particular class 1 solvent in the final product. However, there is a flexibility. If the potential residue of solvent contains less than the level prescribed in the permitted limit, it is not necessary to screen the final product for that particular class 1 solvent. To make it clear, let us see how it works. If the toluene content is 890 ppm in the final product at the maximum limit, benzene content should not be more than 2 ppm in 890 ppm of toluene. Many suppliers supply toluene with not more than 500 ppm of benzene. So even if you have maximum 890 ppm of toluene in the final product, the benzene content would be approximately 0.45 ppm. It's a simple calculation. 500 milligrams of benzene in 1 million milligrams of toluene would work out to 0.45 milligrams in 890 milligrams of toluene in the final product. You can also refer IS 537 of 2011, which prescribes a limit of not more than 500 ppm of benzene in toluene. It is demonstrated with a validated method that the class 1 solvent is not more than 30% of the specified limit in a suitable intermediate or in the final active substance. Let us understand this point. If the class 1 solvent is less than 30% in a suitable previous intermediate or final product, it is not required to screen for class 1 solvent routinely. For example, in case of benzene, it is not more than 2 ppm. 30% of 2 ppm is approximately 0.6 ppm. So, if it could be demonstrated that the benzene content is less than 0.6 ppm in a suitable intermediate or final product, the routine screening of the final product could be avoided for class 1 solvents. Supporting data should be presented on 6 consecutive pilot scale batches or 3 consecutive industrial scale batches. See the condition here. The data from 6 consecutive batches from a pilot scale or data from 3 commercial batches is necessary to support deletion of screening routinely. Another important point here is that the batches manufactured at pilot scale also should comply to routine GMP controls, and the process is same as the commercial process. The pilot plant data should be readily available for any inspector to review the data. The specification for the originator solvent used includes a routinely performed test and limit for the class 1 solvent. Also, if there is a control in the originating solvent, the testing could be avoided for routine clearance. That means there should be a specification to test for class 1 solvent in the originating solvent. There should be an approved specification of benzene content in toluene or acetone, which is the originating solvent. When class 2 solvents are used as starting materials or solvents, they should be normally routinely controlled either in a suitable intermediate or in the final active substance, depending on the steps of synthesis in which they are used. So, when class 2 solvents are used as starting materials or as solvents, they should be screened appropriately. In all cases where a class 2 solvent is used in the last step of a synthesis, it should be routinely controlled in the final active substance. This is required because there are no further steps to monitor the presence of class 2 solvents. That's why all the batches of active substances should be tested for residual solvents. Class 2 solvents used prior to the last step in the synthesis need not be included in the drug substance specification if it has been demonstrated on a suitable intermediate or on the final active substance that the content of class 2 solvents is not more than 10% of the acceptable concentration limit. Example, acetonitrile at 41 ppm. Similar situation as in class 1 solvents. Here it is necessary to establish that the class 2 solvent is less than 10% of the ICH limit. In this acetonitrile example, 10% of 410 ppm is 41. The same strategy for all class 2 solvents may be adopted. If tested, the content of class 2 solvents in the final active substance should of course meet the requirements of the relevant guideline. So, it is a requirement that it should be within the limits when tested in the final product. But however, statistically it will pass. I hope that you understood the intricate requirements and flexibility to reduce the testing of class 1 solvents and class 2 solvents with a system of evaluating data from 6 consecutive batches of pilot scale or 3 commercial stage batches. This video did not discuss the analytical methodology part. This part also is very important. There are several methodologies described in USP 467 chapter. You may refer that chapter for more details. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.